So now we're going to look at solving a quadratic by the square root method. The best time to do this is if you have a quadratic with no linear term, so there's no bx value. It's also really good if you have an equation in vertex form. Factored form isn't really the most efficient method to do that because you can just set your factors equal to 0 and solve for x. The only exception to that is if you have an equation in factored form and the factor repeats, you could do the square root method on that. So let's look at an example. Here we have y equals 10x squared plus 70. To solve by the square root method, we need to set our equation equal to 0 and solve for x. The reason why we can use the square root method is because there's no linear term. So you can either subtract 10x squared from both sides, or you can subtract 70 from both sides. It really doesn't matter. You're going to get the same answer either way. So let's just subtract 70 from both sides for this problem. Now we need to get x squared alone, and we can do this by dividing both sides by 10, which is going to leave us with negative 7 equals x squared. Since x squared is alone, we need to take the square root of both sides, and when we do that, we need to not forget the plus or minus sign. So now we have the case where we have a negative number underneath the radical, and we have learned that if this happens, that means we have an imaginary number, which just means that it's not a number that's on our normal coordinate plane. So we had to extend the number system to include an imaginary number. And so when we do this, we're going to simplify and use the number I. And I is equal to the square root of negative 1, so we can actually break up the square root of negative 7 into the square root of negative 1 times the square root of 7. This helps us because we know that the square root of negative 1 is I, and then the square root of 7 we just leave as square root of 7. So the solution to this problem is x equals plus or minus I times the square root of 7. And when you look at a graph of the equation we just solved, we see that there are no x-intercepts shown on the normal coordinate plane, and so it makes sense that we're going to have some type of number with an I in it for our solution to this problem. Let's consider one more example. We know we can use the square root method on this problem because it's in vertex form. So we want to set it equal to 0 and solve for x, and the whole point of this is to get the quantity squared alone first, and then you can take the square root of both sides. So I set my equation equal to 0, and then I subtracted 1 from both sides. The only thing I need to do to get my quantity squared alone is to divide both sides by 4. Now I can take the square root of both sides, and again, I'm leaving this as a fraction, and there's really no point to convert this into a decimal because it's going to make your life a lot easier to leave it as a fraction. So let's take the square root of both sides and remember the plus or minus sign. When we do this, we know that we're going to have an imaginary solution because we have a negative underneath the radical. But what's kind of cool is that both of the numbers underneath are perfect squares. So we actually want to break up the square root to help us simplify and make our answer as simple as possible. When we do that, we get plus or minus square root of negative 1 divided by the square root of 4. We know that the square root of negative 1 is I, and the square root of 4 is 2. And so that means our solution to this problem is x equals plus or minus I divided by 2. If we were to consider a graph of this, we actually know what the graph looks like because it's in vertex form. We know the vertex is at 3, 1, and that our a value is 4, which means our parabola opens up. And so that means that on a coordinate plane, our graph would be something like this, so we know there's no x-intercept, so it makes sense that our solution has an imaginary number in it. And imaginary numbers really do exist. It's just an unfortunate name that we gave them. So we have like the real number system, we have imaginary numbers, and it doesn't mean that they don't exist. It just means that they occur when you get like a negative underneath of a radical. And so that's how you can solve quadratics by the square root method and simplify an imaginary solution.